Projectile. An example of curvilinear motion is projectile motion. This is two-dimensional motion of a particle if thrown obliquely into air. When we throw particle at some angle, it moves in a two-dimensional motion. But it is not necessary that the projectile is always two-dimensional motion. In absence of gravity, it may be one-dimensional. Or if we throw a stone vertically upward or downward in presence of gravity, then also it is a projectile. Means when we throw a particle vertically upward or downward, it is also a projectile. Usually students think that the projectile is always two-dimensional. It is not necessary. Projectile may be one-dimensional also. When we throw a particle outside the Earth's surface, it moves in a circular path, that is also a projectile. Now some basic assumption of projectile which we will discuss here is, first is air resistance is neglected. As we know, on Earth air is always present, but we neglect the resistance of air because Earth always exert force while the particle move up or down. The Earth second is Earth's surface is assumed to be flat. We know that our Earth is not flat. But for a small calculation, for a small distance, it can be assumed as a flat surface. The third is acceleration due to gravity is constant. We know the acceleration due to gravity vary from point to point. It also vary from height and depth. It varies with variation in radius of curvature of the Earth. It depends on so many factors, but we will consider it to be constant. Means the projectile which we are studying is for very short range order. The distance traveled by the projectile, when this is our Earth's surface, we can take it as flat. When the distance, if I throw the particle, it fall at a very small distance. Suppose the distance is 100 meter, 200 meter, this height is 100 meter or 200 meter, then only the Earth's surface is considered flat and the acceleration due to gravity is assumed to be constant. So we are studying projectile for a very short range and for a very small height. See the example of projectile. When we throw a particle at some angle, see the motion of this particle, this ball. When we throw this ball, in presence of gravity, G is acting downward. In presence of this gravity, this ball move in a curved path when it is thrown at some angle. See the path of this ball. If we increase the angle of projection, it will move like this. This is a parabola path. Now let's watch the motion of particle thrown at different angle in presence of gravity with a speed of 20 meter per second. This is a particle. I will throw it at different angle and watch the motion. Now if you watch the motion of this particle and this particle will have the same range. If I increase the angle of projection, first the range, the horizontal distance increases. But if I go on increasing the angle of projection, it starts decreasing. And finally, if I throw vertically, the height increases. This white particle, this white ball, reaches a height of 20 meter maximum. This is the maximum height attained by the particle. So if I want to throw a particle at maximum distance, so I have to project this blue color ball has reached the maximum horizontal distance. For this, the angle of projection is 45 degree. If I want to throw a ball at a maximum height, then I have to throw it vertically upward. Projectile on horizontal ground. We will discuss first the projectile when a particle thrown on horizontal ground. The clip which I have shown you. Suppose this is a particle, this is our x-axis, this is our origin. This is our x-axis, this is our y-axis, this is our origin. This is the surface along Earth. We'll take x-axis along Earth, y-axis perpendicular to Earth. The acceleration due to gravity will act vertically downward. So if I throw a particle with some speed v0 at an angle theta with horizontal, then we can say the horizontal speed of the particle is v0 ux, that is equal to v0 cos theta, whereas the vertical velocity of the particle initially is uy, that is equal to v0 sin theta. As we know, ax that is equal to 0, whereas ay that is equal to minus g. The acceleration along x-axis is 0 because the particle is pulled by gravity, it is vertically downward. Now the second thing, the velocity of the particle, we will use v is equal to u plus at. As we know, the acceleration is constant, so I can say v is equal to u plus at. This equation is valid for which we have already discussed in one dimensional motion. So vx, v is equal to u plus at because a is constant. So I can say vx is equal to ux plus ax into t. As we know, ax is 0, so we can say vx is equal to v naught cos theta, that is equal to ux. So the velocity of the particle along x-axis will remain same. In the same way, we also know s is equal to ut plus half at square. Now we know the displacement along x-axis is ux into t plus 1 by 2 ax into t square. Now we know ax is 0, so displacement along x-axis can be written as x, which is equal to ux means v naught cos theta into t. This is our second expression. In the same way, Vy is equal to uy plus ay into t. We know ay is equal to minus g. So the velocity at an instant along y-axis is uy. We know uy is v naught sin theta. So it is v naught sin theta. This is uy. It is v naught sin theta minus g into t because ay is minus g because acceleration due to gravity is acting vertically downward. In the same way, I can say y is equal to uy into t. Displacement along y-axis is uy, y is equal to uy into t plus 1 by 2 ay into t square. So uy, we know uy is equal to v naught sin theta, so I will substitute it here. So v naught sin theta into t, ay is minus g, so I will substitute it here. It is minus 1 by 2 gt square. So this is the displacement of the particle along y-axis at any time t. This is the displacement of the particle along x-axis. This is the velocity of the particle along y-axis at any time t. This is the velocity of the particle along x-axis at any time t. At highest point, when we throw this particle from here origin, it moves upward. Its height from the ground increases. When it reaches the maximum height, this is also the maximum value of y. When the particle is at the maximum value of y, its Vy becomes 0. So if I put Vy is equal to 0 in this expression, we know Vy is equal to 0, then we get t. If I substitute Vy is equal to 0, then we get t, that is t1 is v0 sin theta by g. And this is the time taken by the particle to reach from point of projection to the highest point. This time is also called time of ascent. This time is also called time taken to reach the maximum height. If we substitute the value of this t1 in this expression y, we know y as a function of time. If I substitute t1 here, then it will give me y maximum. So y maximum is given by, is written as h, so it comes out to be, it is v naught sin theta into t1 minus 1 by 2 g into t1 square. The value of t1, that is v naught sin theta by g, I will substitute it here in this y max. It will give me the maximum height. This is also the maximum height. This is y max. This is the maximum height attained by the particle. So y max comes out to be, y max is equal to v naught sin theta into t minus 1 by 2 g into T1 square, where T1 is equal to V naught sine theta by G. If I substitute the value of T1 here and rearrange it, I will get Y max, which is equal to V naught square sine square theta by 2G. This is also the maximum height attained by the particle during its entire motion. This maximum height is taken from horizontal ground. Now, when the particle strikes the ground, when the particle falls on ground, if you see, y go on increasing. When before striking the ground, y becomes 0. Usually students say before striking Vy becomes 0, but it is not true. Before striking, y coordinate becomes 0, because we are discussing this motion when the particle is in motion. So when the particle strike the ground, the y coordinate of the particle becomes 0. If I put y is equal to 0, I will get time that is equal to, if I put y is equal to, we know y is equal to v naught sine theta into t minus half g into t square. If y is equal to 0, it will give me t, that is equal to 2 v naught sine theta by g. This time is also called time of flight. Time of flight means the total time for which the particle is in motion, the particle is in air. This is t, that is equal to 2 v naught sine theta by g. If I substitute the value of time, that t, in expression x, that is equal to v naught cos theta into t. If I substitute the value of t here, the time means the total time of flight, it will give me the total x covered by the body, and the total x traveled by the body is also called range. This distance is called range. This is our range. If I substitute the value of time in this expression, it will give me a range, which is equal to v naught square sine 2 theta by, this is the range of the projectile. Now, from the expression, that is x is equal to v naught cos theta into t. If I take t is equal to x by v naught cos theta and substitute the value of time in this expression, v naught sine theta into t minus half gt square. If I substitute the value of t here, it will give me y as a function of x, and y as a function of x is this equation. This equation, if you see this expression, so this is of the form y is equal to ax minus bx square, where a is tan theta. I have substitute here tan theta as a, and b as g by 2 v naught square cos square theta, because v naught is constant, g is constant, theta is constant, so I have assumed b as a constant. So this is of the form y is equal to ax minus bx square. This is actually equation of a parabola. For all values, it is a parabola except when theta is 90 degree, because cos 90 is 0, so y is not defined for this theta 90. Theta 90, the particle is not moving on a parabolic path, so it satisfies equation of straight line. A particle is projected with 20 meter per second at an angle of 37 degree with horizontal. Find the time taken to reach the maximum height. Also find its range. Suppose this is our y-axis, this is our x-axis, and we project a particle with a speed of 20 meter per second at an angle of 37 degree. So we know the time taken, first we will concentrate on time taken to reach the maximum height. So the particle will take this time, this t1, to reach this highest point. So we know that t1, that is equal to v naught sine theta by g. v naught means 20, sine 37 means 3 by 5, g means 10. So it comes out to be 6 by 5, that is equal to 1.2 second. So this is the time of ascent also. This is the time taken by the particle to reach this maximum height. Second is find its range. We know this distance is called range. This is range. And range is V naught square sine 2 theta by G. We know V naught square means 20 square. Sine 2 theta means 2 into sine theta cos theta by G means 10. So it is equal to 20 into 20 into 2 sine 37. Sine 37 means 3 by 5. Cos 37 means 4 by 5. G means 10. So this 0 0 will vanish. We get it as 20 into 2 into 3 into 4 divided by 25, which comes out to be 20 into 2 40. It is 40 into 12 divided by 25. It is 40 into 12 divided by 25, which is equal to 19.2 meters. So it is 19.2 meter. This is the range of the projectile. A particle is projected speed 20 meter per second at an angle of 53 degree with the horizontal. Find the time when the velocity makes an angle 37 degree with the horizontal. So this is the particle. This is our y-axis. Let this be x-axis. The particle is projected speed 20 meter per second at an angle of 53 degree. As we know, when the particle is moving upward, its velocity go on decreasing. So the horizontal velocity component is Vx and the vertical velocity will remain Vy. As we can say, Vx is equal to V naught cos theta, whereas Vy is equal to V naught sin theta minus G into T. Horizontal velocity will remain same. Vertical velocity will go on decreasing. It becomes 0 at the highest point and then again it becomes negative. So when the velocity makes 37 degree, this is velocity, it makes an angle 37 degree in upward direction. Let this time be t1. So we can say tan 37 is equal to Vy by Vx. So this is equal to Vy means V naught sin theta minus G into T1 divided by Vx means V naught cos theta. Now tan 37 means 3 by 4, that is equal to V naught means 20, sin 53 means 4 by 5 minus G 10 into T1 divided by V naught 20 cos 37 cos 53 cos 53 cos 53 means 3 by 5. So this become 5, this is 4, this is again 4. So this is equal to 3 by 4 is equal to 16 minus 10 T1 divided by 12. So from here we can say this 4, this becomes 3, 9 is equal to 16 minus 10 T1, or T1 is equal to 16 minus 9 divided by 10, which is equal to 7 by 10, which is equal to 0.7 second. This is the first answer. This is the time when the particle makes angle 37 degree with the horizontal. But again, after some time, let this time be t2. At this instant, the velocity is Vx. The vertical velocity will become negative. Again, the particle makes an angle 37 degree in downward direction. So once it will make 37 degree in upward direction, Next time it will make an angle 37 degree in downward direction. So from here we can say, again I can say, for T2 we can say tan 37, which is minus, because if we take tan 37 upward positive, it is negative, which is equal to Vy by Vx, and Vy is V0 sin 30 V0 sin theta minus GT2 divided by V0 cos theta. So from here we can say minus 3 by 4 is equal to V0 means 20 sin 53 means 4 by 5 minus G 10 T2 divided by V0 cos theta. V0 cos theta means 20 into cos 53 means 3 by 5, which is equal to 3 by 4 is equal to 16 minus 10 T2 divided by 12. So this will cancel out, we get as 3. So minus 9 is equal to 16 minus 10 T2. So T2 comes out to be 25 by 10, which is equal to 2.5 seconds. So the particle in this situation, this time T2 is 2.5 seconds. Again at this instant the particle makes an angle 37 degree with the horizontal in downward direction. A particle is projected speed V0. This speed is V0 at an angle theta with the horizontal. Find the time when the velocity of the particle become perpendicular to initial velocity. Let this be our x-axis, this be our y-axis. The initial velocity is along this line. At an instant when the velocity is, so I can say initial velocity of the particle is equal to V0 cos theta I cap plus V0 sin theta j cap. Velocity at any instant, we can say velocity at any instant is Vx I cap plus Vy j cap. We also know Vx is equal to V0 cos theta I cap, Vy is equal to V0 sin theta minus gt. So we can say the velocity at that instant is Vx means V0 cos theta I cap and Vy means V0 sin theta minus gt j cap. This is the velocity at any time t. This is the initial velocity and this is the velocity at any time t. Now the question says find the time when the velocity become perpendicular to initial velocity vector. So this two velocity means u and v both are mutually perpendicular. This is possible when u dot v is 0. The two vector, initial velocity vector and velocity at any instant, is perpendicular if their dot product is 0. So from here we can say u dot v means, it is u means v naught cos theta I cap plus v naught sin theta j cap dot v naught cos theta I cap plus v naught sin theta minus gt j cap. So if we take the dot product, it will give me v naught square cos square theta plus v naught sin theta into v naught sin theta minus g into t, that is equal to 0. So from here we can say v naught square cos square theta plus v naught square sin square theta minus v naught sin theta into g into t, that is equal to 0. So from here we can say v naught square must be equal to V naught sine theta into gt, because we know cos square theta plus sin square theta is 1. So V naught will vanish. We get time as V naught by g sine theta, which can also be written as V naught cosec theta divided by g. This is answer. See this question. A particle is projected with 20 meter per second at an angle of 53 degree. This angle is 53 degree. This speed of projection is 20 meter per second with horizontal. Find the time. Find the time of flight and L on the inclined plane. This particle falls on an inclined plane which is situated at distance of 20 meter from the point of projection. So we have to calculate this distance at which the point will strike this inclined plane. If this inclined plane makes an angle 37 degree with the horizontal. So first we resolve the horizontal and vertical component of velocity. Let this coordinate be x and y. So we can say the total horizontal displacement, this is actually, this length is L cos 37 degree, and this distance is L sin 37 degree. If we see this triangle, this is L cos 37 degree, this is L sin 37 degree. So we know x, that is equal to 20 plus L cos 37 degree, which is equal to the horizontal speed of the particle means V naught cos 53 degree into t. Second thing, y coordinate. Y coordinate means it is L sin 37 degree, which is equal to V naught sin 53 degree, because angle of projection is 53 degree, V naught sin theta into t minus half g into t square. This is our first expression. This is our second expression. From first, we can say 20 plus L cos 37 means 4 by 5 is equal to 20, the speed is V naught 20, cos 53 means 3 by 5 into t. This is our first equation now. Let this be A. If we put the values here, L into sin 37 means 3 by 5, that is equal to V naught means 20 into sin 53 means 4 by 5 into t minus half gt square means 5t square. This is our second expression B. From A and B, from A, we get 20 plus 4L by 5 is equal to 12t, or 100 plus 4L is equal to 60t. If we multiply it by 5. Similarly, from expression B, we can say 3L by 5 is equal to 16t minus 5t square, or 3L is equal to 80t minus 25t square. This is our expression. From this and this, from this expression, 100 plus 4L is equal to 60t, and 80t minus 25t square is equal to 3L. These two expressions, we get eliminate L from above two expressions. So from here we get 80t minus 25t square is equal to 3 by 4 60t minus 100, or solving it we get 10t square minus 14t minus 30 is equal to 0. Now we can solve it as it is 5t square minus 7t minus 15 is equal to 0. So t comes out to be t is equal to plus 7 plus minus root over b square means 49 plus 4 into 5 into 15 divided by 2 into 5. So t comes out to be 2.57 seconds. We will neglect this negative sign because time can never be negative. So this is the time when the particle will strike the inclined plane. Now if we substitute the value of this t in this expression here, we will get the x coordinate. If we substitute it here, we will get the y coordinate. If we substitute it here, we can calculate L also.